Good morning. Nancy, I just wanted to confirm you can hear me.
Yes, we can hear you well.
Okay, great. Well, good morning, everyone, and welcome to this webinar. Today we're going to talk about reducing energy use and air pollutants from boilers. I'm Barb Good, and I'm with the Small Business Environmental Assistance Program. Also helping with this webinar today are my coworkers Nancy Larson and Larry Sadiq. Nancy will be monitoring the chat and the Q&A boxes. She and Larry are hosting our two presenters at each of their offices. And we really appreciate these guest speakers for being available and willing to share their knowledge and personal experiences with boilers. I'll introduce them in a moment. Before we get started, I do want to thank and acknowledge the Kansas Department of Health and Environment, specifically the Bureau of Air, for sponsoring this webinar. Some logistics about this webinar software is that you all are muted, and if you do have questions, don't hesitate to type them in the chat box or the Q&A box, and hopefully you can find those okay. You may have to move your cursor around to have the bar exposed that has all the buttons. There's also the ability to so-called raise your hand, and if you have a longer question that you don't want to type, we can give you the ability to ask your question verbally. You can always ask any questions anytime to our email address at sbeep@ksu.edu, and those questions we won't answer at this moment, but we'll answer later in the day or anytime after you ask it. This webinar is being recorded and it will be posted at our website at sbeap.org. Here's a look at what we will cover in the next hour. First, I'll give you a brief introduction of our services, then introduce why we're even concerned with nitrogen oxide emissions. You will get to hear from two presenters who work intimately with boilers daily. I'll touch on air quality rules that you may or may not know exist for boilers. And finally, I have a few slides with links to resources that you could explore further on your own. We will have the ability, or we will stop and have you ask your questions and answers after the presenters, and then also at the end. So again, don't hesitate to type them in the chat box or the Q&A box. So if you haven't heard of us, the Small Business Environmental Assistance Program, we're out of Kansas State University and the College of Engineering. We are under Engineering Extension, which is an outreach program, and in Engineering Extension, there is the Pollution Prevention Institute. There's also a radon program and an energy program, and we're out of the Pollution Prevention Institute. The Pollution Prevention Institute is totally grant funded, and one of our larger grants is this Small Business Environmental Assistance Program. Our mission is to help Kansas businesses to comply with environmental regulations and identify pollution prevention opportunities. There are 5 of us located throughout the state. We consider our program a partnership with the Kansas Department of Health and Environment. We work with KDHE to identify what outreach and education that businesses might need and for us to focus on in any given year. We work with mostly air regulations, but also hazardous waste, water regulations. We also do work in energy conservation, water conservation, greenhouse gas inventory and reporting, and also can help with environmental management systems. We are a free service and confidential, mainly free, I should say, to small and medium-sized businesses. We definitely will answer questions to any size businesses that call on our hotline, or large businesses are certainly welcome to participate in webinars such as this or workshops that we might hold. And then this slide has our contact information. We do have a toll-free number that, again, that will answer as best we can any questions you might have. And if we don't know, we will ask the regulatory agencies, either KDHE or EPA, and we don't reveal who we're asking the question for. So to give us an idea of who is, how many people are watching from your computer and how you learned about this webinar, if you don't mind, would you answer these questions? Being a grant-funded program, we do a lot of reporting, and this really helps us to know how to better tailor our outreach. Give you a few more minutes. I mean seconds, not minutes. Still a few more questions. I see some people are still answering questions, so I appreciate that. Okay. I guess you can see, looks like you can share the results here. This, I'll have to admit, this software is new to me, so Nancy will have to just let me know if there's anything that I am messing up on or forgetting.
You're doing good.
Great. Hopefully the viewers, from their perspectives, they can see all this just fine too, which I'm assuming, since we're not seeing any chats yet. And a couple years ago, we hosted a similar webinar, but we focused on when it might be time to upgrade your boiler to a new unit. We published a case study that featured a large school district and a smaller municipality that both had moved from older large steam boilers to smaller condensing hot water boilers, units that fit their current needs. This case study and the recorded webinar from 2 years ago are still both on our website. Oh, and speaking of right sizing, I just like this slide. A more efficiently operated boiler will result in energy and cost savings, but will also reduce air pollutants. So notice these many pollutants that are related to burning coal. According to the U.S. Energy Information Administration, electrical utilities provide 80% of Kansas's net electricity generation in 2014. 57% of net generation came from coal-fired electric power plants. This is actually down a little bit from the previous year as more renewable energy sources were used. And note, nitrogen oxide is emitted from burning coal. And here's a look at the different air emission pollutants associated with oil burning boilers. In Kansas, we have about 450 units that burn oil. As you probably would guess, greater than 90% of boilers in Kansas are fueled by natural gas. And here's the list of those air pollutants, which again includes these nitrogen oxides that we're concerned with today. Now note, this is a shorter list of pollutants. However, there are more than 16,000 natural gas boilers in Kansas. So it adds up to a lot of nitrogen oxide emissions. So why are we so focused on nitrogen oxides? Well, NOx is emitted when fuels are burned at high temperatures. It's one of the main ingredients that make ozone. Ozone is created when nitrogen oxide and volatile organic compounds, or VOCs, react in the atmosphere in the presence of heat and sunlight. This chemical reaction forms ozone. Typically, the highest levels are measured on warm, sunny days, just like we're having recently. Which reminds me, I bet it's not fun working in the boiler rooms right now. Ozone is a gas that's found in 2 different layers of the atmosphere. 6 to 30 miles up in the stratosphere, the ozone layer is a blanket of ozone gas that protects us from UV light from the sun. That's the good ozone. That's the one we've been trying to protect by eliminating certain aerosols, or certain types of freon. However, ozone can also be found in the lowest level of the atmosphere, where we live and breathe, and breathing ozone damages lung tissue. So obviously that's the bad ozone. Some of you may have heard the saying, good up high, bad nearby. So in areas of the United States that are out of attainment for ozone or non-attainment, some boilers are required to limit their NOx emissions, sometimes through controls like low NOx burners. Wichita and Kansas City areas are closely monitoring for ozone. The ozone standards got more strict at the end of last year, and there's a good chance these two cities could become non-attainment for ozone. So KDHE and local air quality groups are focused on outreach and education to reduce NOx and VOCs, and then today our focus is on the NOx. Going to take a break and take another poll to give us an idea of how you'd gauge your knowledge, to give us an idea of the audience that we're presenting to. Oh, and thank you for the person that said it took a while for the poll to pop up. So I'll be sure and give it a good minute. Okay, I'm going to go ahead and end it. Thank you for participating. And I'll just quickly share the results. Well, now we're at the point that you all have been waiting for. I'd like to introduce our first presenter, Keith Holt, from the Robert J. Dole Veterans Administration Medical Center located in Wichita. This facility is a Joint Commission accredited complexity level 1C medical center facility that serves over 25,000 veterans living in 59 counties of Kansas. It is also a teaching hospital providing a full range of patient care services with state-of-the-art technology. Comprehensive health care is provided through primary care, secondary care, and long-term care. Now I will turn it over to Keith to tell us a little more about how he works to optimize boiler efficiency at a plant that serves a large medical campus.
Thank you, Barb. I'm happy to assist with this training. I've worked on and off with Nancy Larson of PPI for more than 10 years. And I understand that increased boiler efficiency not only saves facilities money, it also reduces emissions to the environment. As I go through my presentation, I will share some important operation maintenance tips that help improve efficiency and reduce emissions to the environment. Our facility's total square feet is 464,000. It includes 6 community-based outreach clinics. The boiler plant serves a medical center comprised of a 41-bed hospital, 32-bed nursing facility, and 8-bed hospice care unit. I serve the VA as the boiler plant manager and worked for the VA for more than 33 years in our plant. We have one 300-horsepower Cleaver-Brooks fire tube, 1966, 2 Cleaver-Brooks fire tube, 350s, 1966, and the baby, a 1 Johnson wetback, 1985. It's a 200. These boilers have never been retubed and run about 84% efficiency advance. We started about 12 years ago doing about 98% of everything in-house. I'm a wrench turner, guys. I'm not an academic, so just bear with me. We purchased our own combustion analyzer to our own combustion settings, usually twice a year. We've also invested when time and cost let us train our personnel on all equipment. We also do all our own safety device testing, plant safety twice a year, and third party for safety and board inspections are from the state of Kansas Board Inspector Ron Sleeth.
Next slide.
Okay, to care for your Morrison tube and to get better heat transfer, and this is, just be careful when you're doing this. Take soap and water, minor amount, and clean just the Morrison tube part of it. Just take soap and water, and the buildup will come off, and you'll notice anywhere from 2 to 5 degrees difference in your stack temp when you do that. Clean it off, and then if you feel like after you've got it all cleaned back off, use a light coat of number 2 diesel fuel to keep from getting any rust or anything. We also do all our own refractory repairs and preventive maintenance. We coat our burners' throats with Plixtex when we open them up for annual inspections. Next. This back shelf that you're seeing is an example. We do as much refractory work in-house as we can. On this particular one, we chiseled all that out. We put in the bridge, and then we use different sets of mortar, high temp, low temp mortar. We also graphite the door facings front and back. Every bore once a year prior to Class A inspection, we wash down all the tubes thoroughly. In the manway and handhold plates, we also repack all the valves, replace side glass if needed, and complete any refractory repair. By doing this, trying to do everything 98% in-house saves us money, and the safety device testing, all of it. That way we can put it back into patient care and other things in the hospital.
Next slide.
We installed this RO unit about 8 years ago. We currently have about 92% condensate return, minimal blowdown, and sulfur and polymer costs have gone down. We spend about $150 a month on chemicals, and that's pretty cheap. Our blowdown is minimal, and we use probably 400 gallons makeup a ship. That's it. And you'll get a payback on an RO unit like this. Okay, the picture you're looking at now, the qualified workforce takes pride in its work. I think this ties into everything. If your plant looks sharp and it's maintained, it's safer. You're aware of what's going on. The other thing, it's taking pride in what you're doing, makes your plant more efficient, and like I said, more safe. Our guys have bought into that, and like I said, currently we're about 98% self-sufficient on everything that we do, which saves us money.
And Keith, and can I just add back on that last slide, Barb? If you look at these copper tubes, they shine,
yeah.
And that's just a definite reflection of the quality of work and taking pride, like he says, in their plant, and then that's reflected over on all the other operations there. Next slide. Okay, what you're looking at here is a screen that we have up in the front office, and we're able to look about everything that we have in the plant and the hospital. You have Veeder-Root underground storage tanks to the left screen, top left. You have the building management, top right screen. And you also have the boilers, which are coming off Chesil recorders on the bottom screens. And they give you your O2, your flow of your steam, flow of your water, and you have graphs. And those are being recorded to the hard drive. Tracking peak demand, we do that. We track our natural gas coming in case we had to go to oil, so we would be able to track and do exactly, and same thing on our peak demand coming in on electricity. Guys, if you don't have somebody looking at your bill, look at your bill every month and see what you're doing and track. Check out what your power factors are. The lower your power factor, the more money you're spending. Westar will be more than happy to come out and give you some advice on how to get your power factors up. Yeah, it's pretty big savings. Next. Okay, increased efficiency, better use of power. What we have is at our plant, we set all our own combustion. Now, I know a lot of you with liability or whatever have a company come in and do it. Typically, we'll run our boilers anywhere from 3.5 to about 5 on O2. CO2 as low as we can get it. You know, usually 0 to 10. If we're getting one that's been a little finicky, I might run it at 50 ppm, but very seldom we do that. Sulfur dioxide, 0. Nitrous oxide, we're right around 100 most of the time, and this is on natural gas. Oil, we're pretty close to the same thing, but I think in the context of what we're talking about here, you need to really either train your people and do this, invest in your own combustion analyzer where you can see what's happening all the time. You know, when you have a storm come in like we have right now, you can change the dynamic in your plant. Your O2, your combustion will change. You need to know what's going on. And again, that goes back to our environment. We're putting out less emissions. We're also burning better fuel. Another thing, when your contractor comes in, a lot of times they will set it at 6 to 8 because they don't want to see any black at all when you open it up. I can tell you right now from experience over the years, you can do that and you put a combustion analyzer on there and your CO might be 3,000. You know, just because your O2 says what it is, it's high, don't worry about it. That's not necessarily true. You're not getting it's going to burn. But anyhow, currently we have Interact O2 analyzer and Yokogawa O2 analyzer, and we also use the Interact combustion analyzer. Okay, next. Okay, I want to go through this again real quick. I kind of got ahead of myself. We set this up so we could, the top left you'll see is a fire alarm panel. I wanted to set this up so we could do fire alarm testing, medical gas testing, generator testing, whatever, and still be able to monitor our boilers and so we can stay safe. Where I work, anything over 15 PSI, you have to have an operator 24/7. I'll just kind of go through this real quick. The top monitor is the outside cameras. We have 4 cameras on the plant level. This enables us to dial in and see what we want and gives us the ability to watch everything we need to during fire alarm testing, medical gas test, generator testing, and still monitor what's going on in the plant. The second to the left monitor is where we have a Veeder-Root underground storage tank monitoring screen where we can see and pull up all the tanks and their testing and information and print off, send it to the state, keep it in our record. This screen is also where we have access to our data log sheet that operators fill out hourly. Second screen to the left is our building management screen to access and control all heating and air conditioning throughout the facility. Bottom screens are for the boilers and auxiliary equipment. All this information is stored and can be looked up in the hard drive. To your far left is medical gas alarm, fire alarms, which you monitor and control. I believe this setup is invaluable to the safety and efficiency of our facility. Okay, plant monitoring continue. There was a couple write-ins about what you guys use. We use Yokogawa, and the particular meter to the left there, we use that. We don't send out any of our gauges to be calibrated. We use that particular their deal. And then on the safety device testing, we also use that for high and low limit switches to test. To the right is the Yokogawa O2 analyzer, and we do all the calibration on that also. Next down. This is a Chesil paperless recorder, and it will show you amount of steam you're using, how much gas is going through the transmitter, your O2, your stack temp, your total. this is a really, really good recorder. We have a computer program that goes up to that you on that previous screen, and we record all that information on the hard drive. The chest logs, so it records it. I went through this kind of fast, and I don't know if that's exactly what you guys were looking for, but hopefully it's a few hints on what we do. If you don't take anything else away from this is, invest in your people, train them, ask questions. And, I've got grandkids and stuff. I want to run efficiently, just not because it saves me money to take care of veterans, but it's the right thing to do. So thank you.
Thank you so much, Keith.
Yes, Keith, thank you. Did a great job. I would not have known that was your first webinar. We really appreciate that, and we appreciate those tips that you had that aren't necessarily about spending money, but about how you conduct your operations and maintenance. So thank you for the tips, and the RO water feature. That's something it seems like it's worth checking out and calculating a payback. I see we do have a question. Let's see. What statute requires a 24/7 boiler operator for PSI at 15 and over?
That's federal.
And would that be a safety regulation? Because I don't recognize it in the environmental world.
Yeah, you don't have that, but you're required to have a 24/7 operator at federal facilities, or your prisons that are federal or wherever.
Right. So realizing that the VA is a federal facility.
Right.
And then beyond that, that's a question for our safety, our boiler safety inspectors at the Kansas Department of Labor.
That's been argued over and over. A lot of states require it. I believe Washington does, Michigan, Minnesota, some different ones. I believe, personally, I wouldn't want to work in a plant where I didn't have, and I know it's not possible all over, guys, but I think it's safety-wise, I think it's really a good thing.
Thank you.
And another question, Keith, how much wastewater do you put out to make 400 gallons of RO makeup water? And
it's not quite half. If you're going to use that, probably if I have 400 that we use, then the other part of it's probably 800. It's real close to that. But when we do that, we have next to no blowdown at all. At our facility, we have no, like I said, our tubes, those things are 1966 boilers. We have eggshell scale, if that, so our heat transfer, and that directly relates to the type of water we get back, and also the RO water. And our chemical bill, you can ask around, it's next to nothing.
And do you have a cost, what that costs for you?
On the what? On the RO system?
Yes.
The RO system, about 7 or 8 years ago, I believe we put it on, and that was brand new softeners. The chlorine, it takes chlorine out of the water, and then also the RO system. I think it was right at $20,000.
Did you say that was it had a return on investment in about 5 years, right?
Somewhere in there. We currently spend on everything in the hospital about $6,000 a month, our water bill. And we're right at 1 million gallons. But the boiler plant, what we have, I don't know, 50,000, 30 to 50,000 gallons, real close to that.
Thank you, Keith. And thank you for those who asked the questions. We'll continue. There was a question, Keith, that's not related to you, but prior to your slides. The fact sheet is available, and I will just plan on emailing it to all those who registered just for convenience. So thanks for asking about that fact sheet. So Keith, thanks again. And we are going to move on to our second presenter. We are so pleased to have the knowledge and expertise of Bob Collins, who has more than 32 years experience with conducting inspections for insurance companies. Presently, Bob is a senior equipment breakdown risk engineer with the Chubb Group of insurance companies, where he's been for the last 20 years. Bob served 6 years in the Navy, where he specialized in boiler and power plant operations, was an automatic combustion control supervisor, and a Woodward Governor specialist. Bob has a Bachelor of Science degree from Baker University in Business Administration. He has numerous licenses and certifications related to boiler, refrigeration, and electrical expertise. And I really appreciate Bob reviewed the questions that you all asked or said you were interested in learning about when you registered, and actually revised his presentation to address those questions. So I really appreciate that, Bob.
Thank you.
And Bob will be operating the slides from Larry's office. And so are you guys ready to go? I just need to share the screen.
We're working on it. Can
Okay. I do not see your screen yet. I stopped my screen, and then you may have to pick it up. Okay, now it's starting. Yes, we see it. Thank you.
Okay. Well, thank you, Nancy. And first, I wanted to thank everyone for being here today, and I want to thank for the opportunity to come and to go over some of the things that you guys had put on your request as far as information. I work for Chubb Insurance Company. I'm a licensed state. I do the boiler inspections. Similar to what Keith has, the state do the inspections, and they do on the federal locations. I am licensed through the state as a special inspector, and I do the inspections on clients that we carry insurance on and renew the state boiler operating permits. And we do the internal inspections, the external inspections to check all the safety devices, very similar to what Keith had mentioned earlier. But we also take a look at other areas, more encompassed of the entire operation, whether it be a manufacturer, whether it be a municipal utility, a power plant, any kind of operation. We look at the entire equipment, the boilers, the electrical, refrigeration, air conditioning, things of that nature. But Nancy, we're trying to go to the next page.
You may need to click on your screen. Click on the screen once and then try advancing.
Okay, we got it. The agenda today is going to be on combustion efficiency. We're going to talk about condensing boilers, cascade boiler systems, hybrid boiler systems, and boiler retrofits versus replacement, and then there'll be a final question and comment section. What is the boiler marketplace looking for today? They're looking for more efficient, more energy efficient designs, more cost-effective systems with the latest technology, and sustainability. Sustainability is the key word in the boiler marketplace, because technology is changing so fast, and systems are being introduced to the customer to try to increase efficiency and reduce O2 gas. How is combustion efficiency measured? If you go to ANSI Z 21.13 2000 edition, it talks about steady state operation, full load operation, and we look at temperature of 80 degrees entering water. What isn't in the calculation, however, is probably where we as a user could actually influence that, and that's jacket losses, purge losses, combustion air and flue gas losses, standby losses, and pipe, steam, and hot water losses. If you look at this graph, you'll see the boiler efficiency as a function of fuel and air input. And what I want to get across on this is let's use natural gas as a fuel. If you look at 85% efficiency, your exhaust stack temperature should be around 270 degrees. And that is, if you look at as the exhaust, your flue gas temperature goes up, your efficiency goes down. How the combustion process can be improved. Flue gas losses account for about 20% of energy loss. Improvement opportunities are converting fuel to heat more effectively, reduce excess air, that's a real key right there, excess air, improve heat exchanger efficiency, ensuring the jacket casing is tight so no air heat entering or leaving the jacket. Boiler heat losses and steam hot water pipe losses. If you go into a boiler plant, and I'm sure Mr. Holt's facility down there, I've been in there several years ago, but the steam piping there is insulated. But you'd be surprised a lot of facilities that do not have all their piping insulated. But anyway, the heat loss from uninsulated pipe, 180 degrees, you're losing about 272 BTUs per foot. And the heat loss from insulated 180 degree pipe is 18 BTUs per foot. Heat loss from insulated 130 degree pipe is 9 BTUs per foot. Well, what we figure is about 1% average in heating bills is because of loss of non-insulated piping. And one of the other things, and Keith had mentioned this too, if you look at the graph or the bullet point there, it says unburned carbon. Energy in unburned fuel or carbon monoxide that exits the stack. That is a real key, and that's why we recommend doing combustion analysis several times a year, just to make sure that we have optimum combustion and that the fuel to air ratio is perfect, because it could cause sooting, and that will increase your cost. Moisture in the air, energy required to heat water in the combustion air from ambient to stack temperatures. And if you look there, it's about 0.1 to 0.4%. So those two areas that I focus on a lot, because that could increase your overall cost. I want to talk a little bit about introduction to condensing boilers. There's a lot, and we insure a lot of hospitals in the state of Kansas, and a lot of them are being retrofitted now, from the old 40-year-old boiler to the new condensing boilers. And the reason being is because the efficiency rating is so high. It's 99% on some of these boilers. But you can operate the boilers at optimal efficiency. Condensing boilers represent an opportunity to decrease initial capital investment requirements. If you look at the benefits of these high efficiency boilers, there are lower operational costs. They reduce the hot water system design temperatures. The emissions reductions, the low NOx reductions is very critical. Smaller equipment size. If you look at boilers 100 years ago, they were in schools, for example, they were, some of them were a story and a half tall. Nowadays, you can do the same kind of heating with boilers that are probably 3 foot, 4 foot tall in series, several in series. Smaller equipment size and increased venting flexibility. One of the things that they do now with these new boiler installations is they bring the air from the outside. It's piped into the boiler, and then the discharge is piped outside. through the roof or the venting apparatus. So you don't actually have to have the combustion air in the space itself, which adds to your efficiency. All boilers condense. If you look at this slide, the copper fin boiler at the very top there, and you can see it's corroded. And these are basically, it's a heat exchanger type tube that has fins on them. On the right-hand side at the top is the steel tube. These are division wall tubes, probably on a utility boiler, could be generating tubes. And then on the far left on the bottom is a Cleaver Brooks. This is what Keith has in his facility. This one here's a lot smaller though, but they're steel tubes. And you can see the corrosion on the tubes, and that's pretty much, because it condenses, the water gets below a dew point and it sweats and causes condensation. The flex tube in the middle there, that's probably, there's a lot of flex tube boilers out there, bent tube type boilers you'd see in the utilities. And then on the far right is cast iron sectional boilers, and they do corrode also. They do condense. Non-condensing boilers, I'll just briefly go over this slide and the next one. But non-condensing boilers, if you look at the very top, you have the flue gas losses to dry and moist, and jacket losses. And then the heat input goes to the load, and that's where you get your thermal efficiency. Now, condensing boilers, on the other hand, the moist air actually goes to the load, your jacket losses are reduced, and your thermal efficiency is increased. And the way they do that is that there are two stages of condensing. Common system conditions that contribute to condensing operations are during startup, operating below 130 degrees, and that's because that dew point of the water. Short cycling systems, and that's basically where the boiler comes on, comes off, comes on, comes off several times and cycles all the time, and that affects the efficiency. Poor venting, if you look at the far right there, you'll see the way that system was vented was incorrect. Controlled by boiler management systems, night setback or night shutdown, where the setback might be if you've got a high pressure boiler and you have an operator. A lot of jurisdictions do this, and licensed operator, they will decrease the pressure at night to 15 and below, so they don't have to have a full-time operator. That may suit the operation, but it doesn't do any good for the boiler. Or they shut it down, and the next morning you got to come in and start the system back up. In the industry right now, there is a heat exchanger made in France called Giovanni. It's a water tube heat exchanger. It is stainless steel. There's no need to monitor the pH level. This system has it's a hot water system, but this boiler here will have about 5 gallons of water. It's a closed loop system. It's completely welded assembly. There's no O-rings or gaskets. It's multi-pass pattern for flue gas. There is a first pass non-condensing, which is at the very top where the burner is, and I've got a slide that'll show that. Then there is second pass is condensing. It's counterflow design, stainless steel outer jacket. It collects the condensate and puts it to a drain, and they're ASME National Board certified, constructed. This is a night boiler that has that same heat exchanger, that Giovanni France, and it's made by Lochinvar is the manufacturer. But if you take a look at the boiler on the right-hand side, you can see where it says air, fuel, ignites in the primary burner chamber. Then heat passes through the hydroform coils heated heating the water. Water travels through this secondary heat exchanger, and then water condenses and escapes through the drain. And there's a drain at the very bottom on the right-hand side. The flue gas, the excess flue product exits through the provided PVC piping. And this is where you take the PVC pipe and you bring in your air, and then you exhaust it too. And you'll see these systems here in a second. This is a schematic drawing of probably a Fulton. This is a hot water system. It could be a Fulton boiler. There's several manufacturers. Lochinvar actually makes one of these too. But if you put it all together, this is how it works. Cold water enters the bottom of the boiler and travels upward. It's sort of a reverse counter design. And then your combustion gases flow down through the fire tubes. This is a counter design, and it allows for superheated flue products to reach condensing temperatures in only one pass. If you look at the boiler that Keith had, naturally those are high pressure boilers, but those were 3-4 pass boilers. These are all one pass boilers, and makes it a little bit more efficient. Plus it's hot water. He had steam, high pressure steam. Historically, we've always designed boilers 180-degree hydronic loop set points. We had primary and secondary pumping, protecting boilers from condensing and thermal shock. That was always our goal. We didn't want boilers to condense because it caused corrosion, and we didn't want to add water into the system, that cold water, because it caused thermal shock. And these new designs, those are not problems any longer. But anyway, we calculate the design day load, select one large boiler, and we put a second boiler in for reduction. That's what we did years ago. This is the new systems that you'll see. They'll take the old 40-year-old boiler out, and they'll put in a series of condensing appliances. And these are the night unit that I showed the schematic a while ago. There's 3 of them here, and they work in series. And if you notice the PVC pipe coming in and the PVC pipe coming out in the back, and that's basically for combustion. And you'll notice the condensate drains. It collects, and then there's a neutralization kit, and then it goes to a floor drain. Another area that a lot of people could probably save in efficiency and energy is their vent material. I've been in a lot of facilities where they just basically put up some exhaust ductwork and think that's going to make it. But in reality, there are standards out there, UL standards for vent material, that will actually benefit the customer and reduce their overall costs, so you don't have excess air and excess moisture in the stack. Today, with the new systems, because of the changes in technology, it's so fast. Internet communications in these boiler management systems is critical, and it will actually pay for itself. I know Keith showed his system there, and it works for him. A lot of these systems out here, need to be you can install these internet communication systems to save you money. Cascade boiler systems, the sequence of these systems are up to 8 boilers. You can they come on, and if you look at down there the drawing, they are used when they need to. They're daisy chain type setup, and that's what you would see in a school that had some large steam boilers. Now they put in about 8 of these units. There's hybrid systems where you have one large high efficiency boiler, and it's the lead boiler all the time. And if you get into a situation where the temperature is real low, then the second boiler will come on and sort of compensate for it. This is a before picture of a boiler room that actually had some older boilers. You can see the one on the right doesn't even have a burner, but they made some improvements. You can even look up there. A lot of the piping was not even insulated. And now you can see the after picture. There are 4 boilers, and these are the nights, and all the piping is insulated, and you know, this is what you're seeing a lot in a lot of these companies. A typical boiler scenario today, this is a boiler that is at North Kansas City Hospital, and we're currently right now to this day doing an upgrade. The burner on there, the overall efficiency was in the 70 to 80% range. The combustion analysts showed high excess air. CO was in excess of 50 parts per million. We were upgrading the burner system here. As far as boiler retrofit versus replacement, the boiler is the true driver of the boiler system. Fuel cost, and after years of service, the linkage, the joints, cams wear out, and the burner's ability to keep tight control, the fuel-to-air ratio degrades. So if you look at this boiler, this is the new burner that we put into that boiler, the one on the left, and if you can see, I did an internal inspection. You can see on the picture on the right the tubes. This is a wetback Johnston boiler. It's very large. It's about 25,000 pounds per hour. But I have them paint the tubes with a high temp aluminum so that we can control corrosion and we can see leaks. And actually, that paint, that photo there, that was from last year. So the boiler is pretty clean. Fuel prices, I just wanted to show in the last 10 years, fuel prices have tripled. It went from $3.14 to $9.58. You know, fuel prices, if we had an SUV, we spend average about $25,000 to $3,000 a year based on 20,000 operating miles. But we wouldn't just go out and replace our vehicle. But on a burner system, you know, the case is a little bit different because it runs consistently with heavy use. A burner costing $30,000, you know, over a period of a year, it could burn between $350,000. If you assume a burner can operate 15 years, you're looking at several millions of dollars. What are we paying for? Basically, we're paying the fuel cost. The initial cost for the burner and the service cost is very small compared to the fuel cost as far as a percentage. Other key factors on burners is low installation cost. There's no refractory on the new burners. Low maintenance cost. The burners made out of cast aluminum housing. Production time and cost savings ideals. Magnetic clutch, automatic switchover between fuels. You can go from natural gas to oil without having to have a compressor or any of that other type of equipment. Digital linkage, there's no linkage. If you notice that photo I showed you, there is no linkages at all. There's servo motors that give you a precise burner setting. It's fully compatible with boiler management systems and low NOx. These burners are low NOx. They're less than 30 parts per million for natural gas, and they're pressure atomized oil. There's no air compressor, like I said earlier. No pilot for oil is needed. It pays to retrofit. Boilers have a long life expectancy. Retrofitting an existing boiler with a new burner will maximize the efficiency. And normally you get a payback about 2 years, and the efficiency increase is greater than 10% when you do a retrofit of a large boiler with a new burner. And the reason for that is the O2 level, and you look at the photo on the right, it's the burner heads. The designs are totally different than what we've seen in the past, and they're able to get the O2 trim within criteria, and we're able to have operated 3% oxygen levels. What we did at this hospital, this is a typical scenario. This is the burner that we installed. We looked at our fuel cost, and our savings was about 6.56% with the new burner installation. What caused all this was the EPA came in and did it. That hospital over there is about 1.2 million square feet, and the EPA came in and did a study and made them check their O2 levels, and it was determined that they were basically borderline. So that's why we did this. All 4 of their large boilers are going to be converted. We've just finished with the second one. That's all I had. Any questions and comments? I appreciate it.
Bob, thank you so much. That was great. Again, I got to hear it before, and at first I'd asked Bob to present on for about 15 minutes, and then when I heard his presentation, I just thought everything he had was so important that I would rather take up this webinar time with this. And I do not see that anybody has written any questions. Could be that you're so thorough. I will, when I send out follow-up information, if it's okay with you, Bob, I'll send your contact information. They could always call you with questions.
Yes, that's fine.
Okay.
That's perfect.
So because we're getting close to the hour, I'm going to move on. But Bob, I just cannot thank you enough for your time. I know you're super busy, and we really appreciate all this information.
No problem. I appreciate the opportunity to be here.
Good deal. I'm going to launch one other poll. We're going to move into a couple slides on regulations, and this is just to confirm whether or not you all know whether your boiler might be subject to an environmental regulation. If you know that it is, but you're not sure whether it's this 5D or 6J, 5D is if you're a major source, and 6J is if you have a boiler that is not natural gas. If you have a smaller, if you're a smaller facility, you might be subject to 6J. And a lot of you don't know, so don't hesitate to contact us afterwards, and we can help you evaluate whether your boiler is subject to a regulation or not. Okay, well, thanks. It looks like most people don't know, and like I said, I'm going to fly through these because you can always give us a call. I just put this slide in because there is a regulatory definition of what a boiler is. We all may think what it is in the industry, but I think one of the types of so-called boilers that's not subject is one that might be in a shop that's used to heat the floor. So if you're not sure whether your boiler meets the definition, just give us a call. And when I say recent, it's been the past few years that there have been air quality rules. I know you guys know probably all your safety rules for boilers, but EPA also has air quality rules. And again, if you're not sure, don't hesitate to call us. And then we have 2 more polls, and just would really like to know whether there's something you learned today that you might go back and try to apply. You know, would you maybe research RO units, combustion analyzer, insulate pipes? That was amazing, the difference that in BTU emissions from not insulating pipes. Would you want to learn more about power factor, or conduct a feasibility study on possibly updating your boilers? And the vent material, I thought that was interesting. So thank you for taking these polls. And after the polls, I'll have resources on funding and technical resources. And actually, Nancy, if you want to talk about, there's one more poll I'm going to offer, but you might want to talk about the equipment that we have that could be borrowed to help with energy efficiency. But I do have one more poll, if you don't mind taking this while Nancy explains our equipment. And this just gives us an idea of whether you felt like you learned something from this webinar or not.
And I think you'll have to expand the poll. We're not seeing the last, if you can, we're not seeing the last two options on question 2.
Okay, did that do it?
No, either that or you'll just scroll down. You can scroll it a little bit, or perhaps even the participant can scroll it. That could be it. So yeah, that's probably it. I can't, as a panelist, I can't scroll it. But as participants, if you need to mark number 1 or 2 under question 2, you'll just scroll, use the scroll bar on your right-hand side. But with that said, what Barb asked me to speak on was just the fact that this webinar is being brought to you by our Small Business Environmental Assistance Program, KDHE, but we also have other programs sponsored by EPA and some by USDA, and we've received some equipment funding from those federal agencies so that we can loan it out to businesses that may want to, for example, as part of your preventive maintenance program, or maybe you need to check if a motor is maybe going down or has a problem. We've got an infrared camera that can be used, as well as an ultrasonic leak detector. Through our intern program that operates in the summer primarily, those pieces of equipment are quite busy, but during the non-summer, especially during the winter, we can check those out to you, or we can come to your facility and assist you with some assessment that can be done using that equipment.
Thank you, Nancy. I saw a note, and now I can't find it, that somebody raised their hand, and oh, let's see. So I'm trying to figure out who it is, and actually, would you mind chatting and just confirming that you would like to ask a question verbally? Nancy, do you see it?
I do not see it, Barb. I saw a hand at the beginning of the webinar go up and then it went down. So maybe
okay, so maybe it was accidental. If you would like to ask a question verbally, please chat that you would.
And I'll monitor that. So
okay. Well, just really, I just have a few slides on funding and technical, and I will send these slides along with follow-up material so that you can click on these websites easily. This first bullet is funded by the U.S. Department of Energy, and it's the most comprehensive source of information of incentives and policies that support renewables and energy efficiency in the United States. So I highly recommend this first bullet especially. And something that our program's been working with is this Rural Energy for America program, where USDA has funded a program for rural small businesses, and it helps increase American energy independence. Over time, these investments can also help lower the cost of energy for small businesses and agricultural producers. So at Engineering Extension, where we are, we can assist a limited number of small businesses with the energy assessment and grant application. So if this is something when you get into this and you might, or you qualify, let us know if you'd like our help. Then there's all kinds of resources that's available for expanding on many of these topics that were talked about today. There's Department of Energy has these great tip sheets. That's the second bullet. Just all kinds of things. And then environmental regulations is something that we can definitely help with. let's see. Oh, there was an energy cost savings calculator that I had found, and I'll send that. And then probably most of you know about the Kansas Department of Labor annual conference. It's going to be in Wichita in October, and they always have a boiler track, and there's a lot to be learned with that. So I don't see any more questions, and like I said before, you can always just contact us directly or email, and we'd be glad to work with you one-on-one. I'm so glad you're able to join us today, and I just really want to thank our presenters again, Keith Holt and Bob Collins. So thank you so much for joining. I hope it's not too hot out there in your boiler rooms. Oh, here we do have a chat. Oh, you're very welcome, those of you who are who have participated and got something out of it. So I will end the webinar, and it will be recorded, and stay in touch.